all the great mathematicians, scientists, and philosophers of the ancient world, one person cannot be ignored: Archimedes. He was very famous in his time. In one of his letters to King Hero II, he boasted, "Give me a place to stand, and I will move the earth." Impressed by Archimedes' knowledge, the king decided to give him a special task: to design a ship, the biggest and largest one he could invent. Archimedes immediately set to work. His dream ship would be 55 meters long and would be able to carry 2,000 tons of cargo and crew. And it would have the fancy name of Syracusia. It would be 50 times larger than any ship of that time. Yes, Archimedes had big hopes. But planning how to make a ginormous ship and making a ginormous ship float are two very different things. And Archimedes now had a problem. How do you make something that big float? One day, as he was in a bath and wondering how to solve this problem, he realized that as soon as he immersed himself in the water, some water overflowed. This brought him to the conclusion that the volume of water that overflowed was equal to the volume of the portion of his body that was immersed in the water, and the water was pushing him upwards. This gave us the principle: when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. We have a special name for this upwards force: buoyancy. And this force is equal to the weight of the displaced fluid. Think of buoyancy this way. Drop an ice cube in water. It has a weight, right? As soon as it drops into the water, it displaces some volume of water. The weight of the water is equal to the buoyant force pushing up on the ice cube, and this force is what keeps it afloat. But why do some objects like iron nails sink? They too must be feeling this buoyant force, right? So here's the thing. As long as an object displaces a volume of liquid that weighs as much as itself, it'll float. But if the object's weight is greater than the weight of the water it displaces, it will sink. Iron is denser than water. This means that for the same volume or space occupied, iron would weigh more than water. So even though the iron nail displaces as much volume as itself, the weight of the water displaced will never be equal to the buoyant force required to keep the nail afloat. So comparing the density of an object to the density of water can give us an idea of whether it will float or not. This ratio of densities is called relative density. If the relative density is less than 1, the object will float. But if the relative density is greater than 1, things get a bit complicated. For instance, even though iron has a relative density greater than 1, a ship made of iron still floats. So when the relative density exceeds 1, other factors like shape need to be considered to decide whether the object will float or sink. But what did all of this mean for Archimedes? It meant that he finally had a way to make his ship float. All he had to do is find a way for the ship to displace enough water that the buoyant force would be equal to the weight of the entire ship. The result was a really wacky looking ship, but it did what it was built to do. It floated. But sadly, in recorded history, this ship sailed only once, on a trip from Sicily to North Africa. What happened to the ship after that is not known. However, history has a slightly different version of this story, one that involves a crown and a cheating jeweler. But both teach us the exact same thing: some things float and some things don't.